Hello, this is Greg Krinklaw, the developer of SkyTools, and in this video I want to go into detail on creating an imaging project. So I already have the imaging project tool open here, and it's set up for M81, and I'm going to just select my generic observing program. It's already got the telescope selected. This selection here, you can choose a general purpose project, or if you're doing astrometry, photometry, or some sort of a moving object stack, like say for a comet, or maybe you want to make a video of the motion of an asteroid, you would select this. But since we're doing M81, we're going to just go with general purpose. That tells the scheduler what kind of imaging you're doing, and it uses that information. And I'm going to do another video on the scheduler that will maybe explain some of that. The priority is also something that the scheduler uses. If you set this to a very high or immediate schedule, the scheduler will try to schedule this above all before anything else. I'm just going to set it to a normal priority so it gets equal weight. Here we have whether we want to expose on a single night, multiple nights, or as an ongoing project. Again, this is for the scheduler to use. So if you choose a single night, this tells the scheduler that you want all of the filters and all the observations to be completed in one night. And if it can't do that, it won't schedule it. Multiple nights obviously will allow it to do that. The ongoing selection here tells the scheduler that we're not going to worry about completing the project. So let's say I'm imaging a comet and I want to image it this week and then again next week and then later on. Instead of having multiple imaging projects, I'm just going to use the same imaging project over and over. And so I'm not going to keep track of whether or not it's completed. That's what ongoing means. We're just going to go for multiple nights here. Here we have tracking. Sidereal means just follow the sky. Lunar for the moon, solar for the sun. You're not going to really use those for an eye telescope, or you could turn the tracking off. It's also not a good idea. But we could track the target, and if we are observing a minor planet or a comet, what that means is the telescope will track the object and trail the stars rather than the other way around. But again, since this is M81, we're going to go back to standard sidereal tracking. Now up here on the right, this is something that we haven't talked a lot about. These are the project templates. And I'm going to set this project up, and then we're going to come back to this. So we're going to move on to composition and tiles. Let's do a little bit about tiling here. Let's say I wanted a much larger view of this. Maybe I wanted to include this galaxy up here. So I could have a single tile, or we can do by rows and columns. And I'm just going to add a row, and now we have two images, and I can set it there. And now when we schedule this, it's going to schedule all of our filters for this first frame and then all of our filters for the second frame. So the project is going to actually include two different positions in the sky. We move on to exposure goals, and here we're going to go with our typical signal to noise ratio. We're going to target the main extent of the arms of the galaxy. If we wanted to go very, very faint, it's going to take a much longer exposures, so we're just going to go with the main extent. I'm going to go with higher picture quality, and here we're going to say this is again is for the scheduler. It tells the scheduler what an acceptable night is, and this is the quality grades. So if we go to the scheduler and it just doesn't have a good quality grade, we don't want it to schedule it. So we're going to allow it to schedule for a quality of B or A. So a quality of B or better, but not C and D. So I'm going to set it to B there. Here we can control the sub-exposures. Normally you would just leave this at auto because SkyTools is very good at figuring out the best sub-exposure. But there are times you might want to force this sub-exposure to, say, 2 minutes. There are other times where you don't want the sub-exposure to be longer than, say, 100 seconds. Now, why did I choose 100 seconds? Well, maybe it's an asteroid that's moving through the sky. Maybe we only want 30 seconds because it's going to trail in more than 30 seconds, and we want to have a nice solid round image. So we're going to take a whole bunch of exposures at 30 seconds, combine them together. That's what the maximum exposure would be, or the forced exposure. But we're going to set it back to auto. Here we have observe narrowband filters in moonlight only. That's fairly straightforward. Again, it's for the scheduler. It tells the scheduler that if you've got narrowband filters like an H-alpha or an O3, don't bother to schedule those unless the moon is up. And this is a trick that many iTelescope users use to observe their, to use their narrowband filter imaging while the moon is up because it's a cheaper observing time. And the moonlight doesn't interfere with the narrowband filters as much because being narrowband filters, they only allow a small amount of the background sky in. We're not using narrowband filters, so I'm not going to select that. So what are we doing here? We're going to do your standard LRGB imaging. Now I've got this set up for bin 1. Let's look at this table here. This R here is the ratio of SNR for to obtain the ratio of exposure required to obtain our SNR of 30. So compared to the standard filter, and it has chosen the luminance filter as the standard filter, so it has given that a value of 1. What this means is for the red filter, we're going to have to expose 3.6 times longer to achieve an SNR of 30. For the green filter, it's 4.4, and for the blue filter, it's 5.2. So let's say it's going to take an hour to achieve our SNR of 30 in the luminance. It's going to take 5 hours for the blue. So we really probably don't want to do that. So we can use a trick and customize each of these filters to use 2 times binning. Go into each one of them here and select bin 2. Now by doing that, these are all much closer to 1 now. And that's a trick that many astrophotographers use because the color information doesn't have to be at as high a resolution as the detail. And the detail is going to come from our deep luminance image. So here we are. And that looks pretty good. We're going to go back to the Basic tab. And we're going to save this standard LRGB as a template. So I'm going to click Save Settings. I'm going to call it LRGB. Click OK. Now, the way this works is if we want to create a similar imaging project, say for a different galaxy, maybe M82, we click here, we choose our LRGB, and we click Apply. Now, what that's going to do is it's going to mostly apply the exposure goals that we've selected. It's not going to affect the tiling or the composition because that's really something that needs to be done on a per object basis. But it is going to affect most of these settings: the purpose, priority, expose on, and tracking. One thing I should say is this project template is for a particular telescope. So if you're going to observe with a different telescope, you're going to need a new set of templates. But this is a quick way to create an observing project. So you only have to change a few basic things. You can, if you're going to do the same kind of imaging over and over, just select LRGB and click Apply. Now, we haven't really talked about the Observations tab much. We're going to look at this. Here, what you do is you add an observation. I'm going to click it here. The observations are going to appear down here. You can type all of this in, or we can click Read Hit Fits Header to take the information from a specific image that you've taken. So the idea here is this is a quick way to log your observations. You usually only have to put in the temperature and the humidity and the seeing, and what you feel is the overall quality of the image. And once those are put in, you get a logged observation, 1 5-minute exposure. Up here, this tells us our progress per filter. And since this was one observation in the luminance filter, it's just this tells us that the luminance filter, we've completed one tile of 1, and none of the images are acceptable. There's a bug there. We need to fix that. One of the images is acceptable because it is at least rated as good, which is what I set here. Let's say we needed it to be excellent. Now none of the images are acceptable because it's only good. Go back to good here. Here it is. This tells us the total signal to noise ratio. Now this wasn't a real image, and it didn't really feel that this was had a signal to noise ratio at all, so it selected it as 0, and our completion percentage didn't show up at all either because of that. So what normally happens here is as you add observations, the completion percentage increases for each filter. Some filters will be finished, and when you go to the scheduler, it will only schedule those filters that still need observations until the whole thing is finished. Now, when the whole thing is finished, it will have a completion status of completed. Once that happens, it won't show up in the scheduler anymore because we're only interested in scheduling unfinished image projects. The other thing that's going to happen is this box is going to be checked. It's the archived frozen box. And here's the thing that happens. If you are in the middle of working on an imaging project and a change happens to your imaging system, let's say you swap out a filter and put a new filter in there, you want that information to be updated for your imaging project. Because if you're going to make future observations, it's going to be using that new filter. But once your imaging project is finished, you want it to reflect the status of the telescope or the imaging system when you were using it. So by checking this archived frozen, it means that the imaging system data stored with your imaging project will no longer be overwritten, and it will be just kept the way it was. So normally you would see this with the completed status. And notice I just set the status of this to be completed, in which case it will no longer show up in the scheduler. And that's something you can always do for whatever reason. You don't have to wait for it to automatically tell you it's done. Up here you can type in any notes that you want, things about the imaging project, things that happened during the observing, whatever you want, it will always be there. So when this is completed, you can come back to it and look at it, and it archives the observations that you made. You can also select an observation set, view it, open it up in the atlas, open it up in the overhead sky view, naked eye view. You can import one of your images, maybe it's a final image, maybe it's one of your raw images, and attach it to this observation. Once you do that, you can view the object or view the image in the background of the charts, assuming there's enough information, basically that there's a fits header, so that it's been plate solved. That's mostly what I wanted to show you here with the Observations tab.